So the last set of video lessons is going to be a three-parter. It deals with the three parts of our last culminative set of notes. I call them the last set of notes because it's a culmination of three different sections that I kind of taken things in and out of, specifically 10.5, 10.6, and 10.7. So we're going to start with the first part, which is the material that I took out of 10.5, and that's using roots to solve quadratics. So the entirety of chapter 10 we're going to talk about quadratic equations. 10.1 we talked about how they look visually, parabolas, how to compare them and such. So the last set of notes is essentially us talking about the different types of solutions that we can use to solve quadratics. So the first one is using roots. Now what does that exactly mean? Well, this is the standard form of a quadratic equations. A pretty simple trinomial where it's x squared plus x plus something else. The a, the b, and the c are the coefficients that may appear in front of either the x squared, the x, and then whatever the term is all by itself. Sometimes there is something in front of the x squared, sometimes there isn't. That means there is a 1 in front there. Same thing with the x. Sometimes there is something there, sometimes there isn't. So if there isn't, again, it's a 1, and then you may or may not have something at the end. If you have something, then it's going to be the c. If not, then the c is a 0. So that's the standard form. And to solve them, there are multiple ways of doing it. Well, first of all, you might be given a problem like this. 2x squared equals 2 and 8. Okay, that doesn't look like that very much, but if you think about it, it actually has all the component parts. You have the x squared, you have something in front of it, the a, in this case it's 2. You are missing that middle term. It means the coefficient in front of that x was a 0 because 0 times x would have just made it disappear, so it's not there. And you have the 8, which is our c. Now they're all not next to each other, but at least you have all the component parts, so that's a quadratic function. Now, how are we going to solve this one? Well, fairly easily. You solve it just like any other equation. You isolate the variable. In this case, you isolate the x. So I want the x all alone, all by itself. And how would I approach that? Well, get rid of this 2 first. Divide both sides by a 2. And that's going to yield an x squared equals to a 4. All right. Great, we got to this point. How do we isolate x now? It's a power of 2. Well, if you remember from chapter 8, we learned that square roots were the nemesis of powers of 2. They cancel each other out. The square root and a power of 2 will cancel each other out. So if we squared the x squared here, we'll get rid of this power of 2. But remember, whatever we do to one side of the equation, we have to do that to the other side as well. So we have to square both sides of the equations. Perfect. On the left side, right away, we can cancel out the square root and the power of 2, which yields us the x that we want so desperately. Over on this side, the 4 is a perfect square, which means I can write it as a 2 squared. It's the same thing. And now I can cancel out my square root and my power of 2. Perfect. So that's going to give me x equals to 2 with a small little caveat. It's not just a 2, it's a plus or a minus 2. Now what does that mean? That means x can either be a positive 2 or x can be a negative 2. Why do we have to specify that? Why not just say a 2? Well, because if it's a positive 2, that'll work there. I mean, if you plug in a 2 for the x squared there, 2 times 2 is 4, times 2 is 8, and 8 equals to 8. But if you plug in a negative 2 in there, negative 2 times negative 2 is still a positive 4, which then times 2 will give you the 8. So both a positive and a negative outcome will work for that particular solution. That's why whenever you solve a square root problem, you have to specify that both the positive and the negative outcome will work. And in some cases that's not true, but in almost every single case that's true, and you have to specify that. Good. So let's do another example. Alright, so here we have 3x squared minus 11 minus 13. It's still a quadratic function. It has all the component parts. It's still missing this middle term. A lot of times it's not going to be there, just for simplicity's sake more than anything. So how do you solve this? Well, just like any other equation, you solve for x. And to start that, I'm going to add 11 to both sides. I'm going to get rid of this negative 11, which is going to yield for me 3x squared on this side and a 24 on this side. Alright, perfect. What do we do next? Well, we can divide both sides by 3, and that's exactly what I want to do. And that's going to yield for me an x squared, which equals to just an 8. Alright, now I need to get rid of this x squared. How do I do that? Well, just like before, I can root both. And I root the left side to get rid of the power of 2. I root the right side because whatever I do to one side of the equation, I have to do to the other side as well. Then I can cancel out my power of 2 and the square root there, and my x is all happy all by itself. But now we have this root of 8. It's not a perfect square, so how do we deal with that? Well, you can break down the root of 8 into two separate roots. Root of 4 and root of 2. Now, why did I break it down in such a manner? The root of 2, it's prime. There's nothing I can do about it. It's just going to stay the way it is. But the 4 is a perfect square. Just like we did here, the 4 is a 2 squared, which means once we can put it in this form, we can cancel out the power of 2 and the 2 comes out. So out of here, I can get a 2. And this just tags along and gets written next to it. So that's my answer, except remember we have to specify that it's both a positive and a negative solution. So once you do that, you are essentially finished. That is the answer. So I'm going to conclude the lesson for the using roots to solve quadratics. I'll do one problem like this for the homework. So if you still need some help, look at my homework video, and one of the problems will be worked out using this method. And if you still need more help, just see me in class after school or before school. So thank you very much, and the next video is going to be on the other way of solving quadratic equations, which is going to be completing the square. So that's coming up next.